Hello again. In this video, I'm going to show how to implement OOP into a pre-existing non-OOP program. So the example right over here is a program which I wanted to post for week 5 explaining the powers of using lists, but I chose to opt out of it to save this for this week. So when I start this program, the canvas draws a representation of my turtle over here. Now before starting, one might ask that why would I create the turtle when it is already a Python library? Well, because CodeSculptor as yet doesn't have the implementation of this library, and I got this idea from this website itself right over here, Sculpt. And opening this, if I run this program over here, this is a turtle and it draws a square using 4 different line colors. And as you can see, import turtle, if I try to import turtle, then it will say it will not be able to import. If I run this, they will say import error, no module named turtle. So it was my somewhat kind of mission to implement this. And after lines of code, I've managed to create this program, my logo program. And logo, by the way, stands for logic oriented and graphics oriented, and it is a very old program. It uses MS-DOS, and there is a variation of this program called MSW Logo. Do check it out in Google if you are interested, if you haven't heard about Logo. Okay, for those who already know, there are some predefined commands like fd, rt, lt, bk, etc. And likewise, I have also implemented those same keywords. Inputting some keyword other than the words that the program will understand will give me an error. For example, if I type my own name, that is an unknown command. Okay, so I want my turtle to move forward by 100 steps. As you can see, the turtle moved 100 pixels and it has drawn a line. If I type RT90, my turtle rotates to my right by the specified amount of degrees. Again typing, okay, right. Typing FD 100 again will draw another line in that direction, and in this way I can draw a square. Alright. And there is another command called ht which hides my turtle. So after typing this, my turtle is now hidden and my square is finally drawn. In the log over here, it types whatever commands I have typed, and this is my final implementation. Now I'll be showing my OOP implementation of turtle. So when I run this, note that my program now lacks a prompt text box because I didn't want to implement it, but I'm just wanting to show how two turtles over here, these are now actually objects, have drawn two different figures. Now one turtle has been instructed to go straight, turn some amount of degrees, again go straight and return to its original position, whereas another triangle which has been assigned a different position now draws a circle. Okay, now ignoring the rest of the program, I'm folding the methods of the class turtle. What I have done over here is turtle equals turtle. This is my class, and the parameters over here are the origins, the coordinates of where it will start. So if I change my value to suppose 300 and 250, then running this again will create a triangle at a somewhat lower. Note that previously my triangle was overlapping the circle, now it no longer overlaps. Okay, so the, each time I create a new turtle object, I have to specify where my turtle will first get created, at which position. Over here, this is one object called turtle, and this is another object called turtle1. In this line, I instruct the turtle to move 100 steps forward. I instruct turtle1 to create a circle. Then again, I ask turtle to rotate 127 degrees, move forward 100 steps, and then return home. Note that some of the functions that are previously here in this non-OOP program are still here. Well, that's because I haven't changed the program itself. I have just implemented some certain functions such as def underscore underscore init underscore underscore and the draw turtle, which draws my turtle. Now, looking at the code, my def init initializes my turtle. Now if you see, there is a whole lot of self here, the word self. Now what self does is it refers to that instance of the object. So for turtle, self is referring to turtle. So whenever turtle initializes, POSX is assigned to that turtle. When turtle1 is created, POSX gets assigned to self, that is turtle1. So in this way, I have to write self.posx whatever instances or whatever attributes that are part of these objects. And if you notice, for example, in this non-OOP, my angle is 270, and whatever the values are, these are getting initialized. X1, X, Y1, these variables, are the coordinates for drawing my turtle. So X1, Y1 is here, X2, Y2 is this one, and X3, Y3 is this point. And when I call the draw handler to draw a polygon, then my implementation of turtle is shown. And over here, POSX and POSY is actually the point over here. So when I ask to move forward, POSX and POSY gets modified. So if I add FD50, my POSX and POSY variable is no longer 250. Line list is a variable which stores an empty list at first, and what it does is whenever the turtle moves forward, then it stores the turtle's current position and the position it last was. So the advantage is that for every X in line list, here X represents all the lists within my line list, it will draw a line from X1 and X0. Here this represents my POSX and POSY, and X3, X2, this represents my old X and old Y. So in this case, if I type FD50, I have modified my code so that you can now see my list. Typing FD50, my old value, that is my previous value, is 250, X 250, Y, and my new value is X equals 200 and 250. Now if I rotate my turtle and again draw another line, then I get another list within my line list. So now for every list within my line list, it will draw a line. And so in this way, if I draw, for example, a triangle, if I wish to draw a triangle, then all I have to do is simply instruct the turtle to move forward, and in this way I simply append new lists within my line list, and then draw handler handles whatever lines I have to draw. Okay, so these are all my variables that will be required in the init method of my turtle. So note that uh, whenever my posx and posy is mentioned over here, as I have explained before, so whenever I call a turtle with two parameters, then the turtle will be at those positions as I have shown before. So every time I have to assign self.posx equals posx, self.posy equals posy. Homex and homey are the only two variables I had to introduce in this project, rather the program. And what it does is it actually simply just stores my first position of posx and posy, because every time I move my turtle, my posx and posy changes. However, when I would like to return my turtle to its original position using my home function, then it will create some problems. So I had to introduce new home x for the x of my posx, that is my original position, and home y, the y axis. And then moving on, we have old x and old y, which is also initialized with self.posx and self.posy. Self.lineList, which I've explained just a few moments back, has empty list. Okay, pen state and pen visible. Pen state over here is used to show whether I would like to draw any line or not. For example, let me draw FD50. Now there is, if you notice the documentation, there is a command called pen up. So when I type pen up and then later move my turtle, it no longer draws. Further, if I type pen down and then type FD50, it starts drawing lines. So what it does is, whenever I prompt the program to pen up, it simply states pen state equals false. So whenever unless and until my pen state is true, it will not draw lines. Okay, now pen visible here, if you remember, I used HT. So what it does is, if pen whenever I call HT, my turtle is hidden. Why? Because in my program over here, my pen visible now becomes false, and I've mentioned over here that if pen visible, then only it will draw my turtle. So these are my pen state and pen visible. Angle 1, angle 2 and angle 3 are all related to my turtle drawing mechanism, and then later on my x1, y1, x2, y2 and x3, y3 are all the positions for the points so that I can draw a turtle. Now the definition for my draw turtle method is just the same as that right over here. The only difference that you will notice is that line list is self.lineList, pen visible is self.penVisible. All the variables right over here, from y1, posy, x1, posx, and everything over here is the self dot is added right before it. Also notice that we have to have the self parameter and the canvas for the draw turtle. Now for the update position, it is actually my pause function right over here. I have just renamed it, and also note that global variables no longer apply, because I would like to restrict all the properties of my turtle object within that object itself. So I have removed global x1 y1 x2 y2 blah blah blah, and instead I have all these codes remaining, and I've added self to it. Also note that angle 1 also has self assigned to it. So pretty much the program remains same. All one has to do is to add the self, that is the instance of that object. And one has to be careful also, because incorrect implementation will obviously give errors. Now rotate is pretty much the same. I just show right over here. Global has been removed, everything has been assigned self, and in fact whenever I'm calling self, the update position, I've also mentioned self over here. So as you can see, whenever I unfold my methods, self is everywhere, because without it, it is pretty much impossible to change the instance of that object. So the secret of how to change, or rather implement OP, is to basically include all the methods that are what I should say, part of the class, and then add whatever variables that are required, that is the instances. So apply self over here, that is our Python convention, and then pretty much you are done. And then after all these things, we have to start creating our objects over here in the at the end of our program. So turtle over here creates my object, turtle1 creates another turtle, and when I run this, I get this result. This is turtle number 1, or rather turtle, and this is turtle1. I have created a different version. It's just basically a modification of my last lines. The rest of it is pretty much the same, and if you guess, this is a while loop, and this will iterate 8 times, and if you guess it right, then you should get something like this, a flower. And this is how I get to create various turtle objects. And in case you have to add another turtle, do type turtle1 or any other name and create a new turtle and assign 2 positions. Let us say in this case we assign 90 90, and then we have to draw the turtle, otherwise it won't show. So do remember to type turtle, and a mistake which has to be avoided is to match the turtle1, and then turtle canvas, and when I hit run, this is one and this is the second turtle. In this way we can create a lot of turtles and control them as we wish. So let me control my turtle1. Maybe I should draw a circle, for example. So turtle.circle, and let's run it. Okay, we have to correct our error over here. So as you can see, now we have 2 turtles, one which draws a flower and another which simply draws a circle. Coming to the end of this video, I hope you understand how powerful using OOP is. And being able to convert a non-OOP program into an OOP program is a very handy tool for any programmer. I hope you have enjoyed this video as well as learned from this tutorial. Thank you.